Today's video will demonstrate how to create unit tests for an existing program. Hello, I'm James Helfrich. Unit tests are perhaps the most powerful tool at the disposal of a developer. This allows us to rigorously and systematically test a class to make sure that it works exactly as we intended. This video will demonstrate how to create unit tests for an existing program to verify that our classes work as we hope. We'll do our demonstration in a program that's a physics simulator. And this physics simulator has a point class, also a velocity and acceleration class. We're going to start with writing a unit test for our set x, or our add x function. So what we're going to do here is we're going to put a unit test function right above main that's going to test add x, and we're going to do it for, what test case should we use right now? I think we'll add 0 in this case. Now remember, every unit test has 4 parts. Has a setup, exercise, verify, and teardown. So I'll make comments for that. Now I'm going to use these same 4 parts to every unit test I create. Now let's see here. What shall I do in my setup phase? I'm going to need to have a position object, so point.pt, and I'm going to need to set its position to something. Let me think here. What would be a good value? How about 2.3, and the y will be 4.5. Now I like those because they're different from each other, so it's really easy for me to see if I get my x's and y's mixed up. Now I want to change the value of x by, in this case, 0, because that's my test case. And so I'll say point dot add x, and I will add my variable x. And what am I going to do my verify? I want to make sure that my position had not changed. So I'm going to assert point dot get x still equals 2.3, and I want to make sure my point dot get y still equals 4.5. And I also really want to check that my input parameter x did not change. Therefore, I want to have any unintended side effects. There's going to be no teardown because this is just a simple stack of variables, and they'll take care of themselves. It's always a good idea to add a little comment what the test case covers. Okay, now let's call our function. And we're just going to put the function call at the beginning of main, and then I'll set a breakpoint because I don't really want to execute the rest of the program. I just want to execute my unit test. Okay, I run the program, and the debugger breaks right at my breakpoint, so it looks like my test passed. Okay, the next thing I want to do is move my unit test into its own file. So I'm going to create my own header file, and I'm going to use the file name to be the same as the class that I'm verifying. So point.h is my class, so I'm going to call it test point. So I'm going to first call this class test point, and I'm going to take the code from my main, and I'm just going to copy it or cut it and paste it into here. And I'm going to make this guy private. And I'm going to have one public method, and this public method will be run. So the only thing the client will ever do is call test point run. And right now, test point run is only going to run my one unit test, which is test add x 0. Now I need to pound include point.h because, well, I'm going to be using the point class. And I'm also going to need to pound include cassert because I'm going to verify with asserts. At this point in time, I should be just about ready to go. There's just one little less detail I have to do. Sorry, it's off screen. I have to say pound include testpoint.h so I can then execute it. And now instead of calling the function under test, I'm going to call testpoint.run. And when I run this program, then I'm going to set my breakpoint again, and hopefully it will run the unit test and stop right after the runs, which means all my unit tests pass. Excellent. At this point, I'm going to add some comments to my test class. Every class should have a comment block, and I'm just going to reflect the fact that this guy right here's job is to test point. Okay, we have one more defect we need to fix before we start creating more unit tests. And the problem is that I'm calling points getters and setters in order to access its member variables, but I really want to isolate just one function in the unit test. So I don't want to use this public set x and get x. So what I'm going to do is I'm going to make test point a friend to point. And this allows me to have access to point's privates. So now my setup is not going to access any of point's functionality. My verify is not going to access any of point's functionality. In fact, the only function I should access a point is going to be add x, which is the function under test. And sure enough, this is going to work. Outstanding. Perfect, my breakpoint got hit. Okay, I paused the video and wrote a whole bunch of unit tests for the constructor, for the getters, for the comparison operators, and add x and add y. But when I ran the program, something really weird happened. Now notice this, my value for x is 6.399999, and it's not exactly equal to 6.400001. Isn't that weird? So what's going on here is that floating point numbers are approximations. And so whenever we do math with the floating point numbers, it gets off by a little bit in the last digit of accuracy. So what we need to do is we need to create a new method to help me test it, and I will call this close enough. And it's going to take two doubles, the value and the test, and I want to see if it's within the tolerance. And I'm going to give it a really tiny tolerance, and then now the tests are going to pass. So now I'm going to call this close enough between the value and the test, and give it to like a thousandths place of accuracy or something like that, and it's going to be absolutely close enough. Good. The test pass. Okay, the next part of the demo was to show you how easy it is to create unit tests. So I'm going to take these 4 unit tests here for the equal sign, for the x is different and the y is different, and I'm going to do the not equal sign corresponding to it. So I'm going to copy these 4 guys, and I'm going to change it from equals to not equals, and then I'm going to go down and redefine those methods. Okay, so I'm going to copy the equals version of each one of these, and then I'm just going to paste it right below. And what am I going to need to do for each one of these? Well, first of all, I'm going to need to rename it. Otherwise, I'm going to have a duplicate here. So this is called not equal. Okay. I'm going to change the default result from false to true. And then I'm going to say the not equal. And now this better be false. And I'm going to do that same change for each of these. Notice how my setup changes the object under test, the parameter, and the return result. And I have to check each one of those. Now I'm going to apply the same change to not equals for x is different, and do the same thing for y is different. Now, because each of these unit tests look very similar, creating 3 unit tests is really fast. It should be no more than a minute or 2. And that's the difference between writing code for a unit test and writing code, production code. Unit test code is very linear. Copy pasting is really helpful. It's meant to be straightforward and easy to understand. It's not meant to be efficient or complex or clever. And it all works. Okay, so now I'm going to create a unit test for my add method. And so I'm going to create a new thing. I'm going to call it test add. And this is for stationary, the simplest test I can think of. And what I'm going to do is I'm going to copy the code from my previous unit test and I'm going to modify it. And let's see here, I'm going to take this guy right here and I'm going to modify it and add when not moving. Now notice how I need to have an acceleration, I need to have a velocity, and I also need to have a time. And I'm going to set the time to 0. And let's see here, my acceleration, I got to use my public method, set dx and dy, and my ddx and dy, my velocity set ddx and dy. And then when I assert, I got to assert that my velocity did not change and my acceleration did not change because I have no intention of changing those parameters. Okay, when I run the program, it works. My breakpoint gets hit in main, which means no asserts have fired. Wonderful. Now, I'm not 100% happy with this because notice how I call the public methods in accelerate and velocity to set the values and as well as my public methods to check the values. I would like to access the member variables directly. And how do I do this? Well, I'm going to go into my velocity class definition and I'm going to make test pointer a friend. And I'm going to do the same thing with my acceleration class. I'm going to go into here and say class friend test point. And now this gives me the ability to access acceleration and velocity's member variables directly. It's always a goal that we only call one function and one function only in a unit test, and that is the function under test. We don't want to rely upon any bugs which may be in any other class, including acceleration and velocity in this case. Just take me a second to finish this up, and then I will verify that my unit test still passes. All right, let's run it. And everything works perfectly. Outstanding. Okay, it took a few minutes and I created a bunch more unit tests. I'm going to add a stationary, which I already did, no time, so I have acceleration, velocity, but no time. Moving 1 second, moving 4 seconds, accelerating 1 second, accelerating 4 seconds, and then both accelerating and moving for 1 second and 4 seconds. So let's take a look at one of these. I'm accelerating for 4 seconds, my velocity is 0, my time is 4 seconds, and I have to put the little distance equation in there to remind me that I did the math right. And then, of course, after I did the math by hand, I want to make sure the program did the same. And of course, things get a bit more complicated when I have both the acceleration and velocity and a time of 4 seconds, so I really had to do the math. But when I'm finished, then all my unit tests pass the way I want, which means I have a thorough exercising of my class. You can learn more about creating unit tests in the unit test chapter of the software design textbook.